All right, Matsu, last lesson of 2021. We've got lesson 13-4, and we're going to just look at how to use volume formulas. Because like I've said before, most of the test is going to just be, hey, here's a prism, and here's the three sides. What's the volume? Oh, and then all you have to do is multiply them. That's what you did like in 7th and 8th grade. That's basic volume. You probably even did that in 6th grade. That's basic volume. Okay, we actually need to know how to use these formulas. And have a little bit more difficult shapes like stuff with lateral heights and things like that using our trigonometry that we've done this year. So this lesson is just kind of a review of all our different concepts and how to do some of the harder problems where they maybe give you the volume, but then they're looking for other pieces of information. So here we go. It says, describes the steps to isolate R in this formula. Volume equals 1/3 pi r squared times height. So it looks like the volume of a cone. And what if we wanted to get r by itself? What would we do? We'd have to get rid of that 1/3, so probably multiply both sides by 3. We'd want to get rid of this pi and this h, so we'd probably divide both sides by pi and h. And then we'd have to get rid of that squaring, so we could take the square root of both sides. So several steps to get r by itself. So in general, what we're going to do is we're going to write down the correct volume formula for the problem. We're going to plug in the things that we know, and then we're going to solve the thing we don't know. Let's do it. Here we go. Number one, we've got a cone. So in this cone, I know the volume and I know the height. I want to find two things, the radius and the lateral height. So I know the volume, and the volume for a cone, remember it goes to a point, so I only have 1/3 of the base area. The base is a circle, so the base area is pi r squared. And then I multiply it by the height. All right, let's plug in the things that we know. We know the volume is 120 pi. So instead of volume, I'm going to plug in 120 pi. 1/3 is a constant, so it stays. Pi is a constant, it stays. I don't know r squared, so it's going to just stay r squared. I do know the height. The height is 10. All right, so I need to get r by itself because I really want to know what r is. Let's just do it one step at a time instead of doing everything all at once. Let's deal with the 1/3 first. In order to undo the operation of multiplying by 1/3, we can multiply both sides by 3. So if I multiply this side by 3 and this side by 3, because 1/3 times 3 is just 1, right? So 3 times 120 is 360 over here. And now we have pi r squared times 10. Okay, I don't like the looks of this pi. I need to get rid of it. So I'm going to divide both sides by pi. Well, those pi's reduce. So now I'm left with 360 equals r squared times 10. Getting closer, let's divide both sides by 10. R squared equals 36. Square root both sides. Aha, r is 6. So our radius is going to be 6. Okay, so it says find the radius. The radius is 6 centimeters. Now they want us to find the lateral height or the slant height over here. Well, what I have is a right triangle with 10 of my height, r of my radius, and the slant height. The slant height is the hypotenuse there. So to solve this one, I'm going to do 10 squared plus r squared. We just found out r squared was 6. Plus 6 squared equals the lateral height squared. So this is 100 plus 36. So this is 136. We're going to take the square root of both sides, and we're going to see if this reduces at all. So 136, let's see. That would be 2 times 68. Yep. And this would be 2 times 34. And this would be 2 times 17. So looking at that, do I have any pairs? Yes, I do. I've got a pair of 2's right here. So that can reduce. Okay, and then do I have anything left? Yes, I do. I've got a 2 and a 17 left. All right, so the slant height, after it's been reduced, is 2 times the square root of 34. So slant height, or L, or lateral height, I just use all those interchangeably, is 2 times the square root of 34 centimeters. If you wanted to do 2 root 34, so I've already pulled up 2 root 34 here, you just hit this side-to-side button if you wanted an approximation of it. So that is approximately 11.7 centimeters, or approximately 12 if you wanted to round to the nearest whole unit. Let's say that's approximately 11.7 centimeters. There you go, we got our approximation there. Next. All right, this one's a bit of a sticky wicket because I really think that you've forgotten how to do regular hexagonal prisms, or just regular hexagons, in fact. So let's redraw the hexagon here and see if if any of this even remotely rings a bell to you, which I know some of you it won't, which is fine. It's okay to relearn material here. So the theory behind regular hexagons was that you could put a circle on the outside of the object. And so if there's a circle going around the outside of the object, we got 360 degrees here. Well, if I would connect what would be radiuses, because the circle is touching the corners here, I could ask myself, how many degrees would this be? Well, if I took 360 and divided by 6 sides, I'd get 60 degrees for each of these. So that's 60, that's 60. All these would be 60 degrees there. We found out that the apothem cuts one of those sides directly in half. And so this was the apothem. This is half the side, and this is the radius of the hexagon. Now, since this is 60 degrees here, and then the apothem cuts it in half, this is actually a 30, 60, 90 triangle. If you remember back to that unit, we just wrote down the triangle instead of the entire shape. So our 30 is here, our 60 is here, here's our 90, and we said in a 30, 60, 90 triangle that the side opposite the 30 degrees is B. The hypotenuse is 2 times B, so it's twice as big as that side. And then the hypotenuse would be B times root 3. So in this problem, they're telling us this apothem, this part right here, is 4 root 3. So if B root 3 is 4 root 3, B has to be 4. And 2B would have to be 8. Now, we also said that the area of a regular polygon was equal to 1/2 the apothem times the perimeter. If none of this is making any sense to you, go back to the video It's the last video in Unit 7, and we did this before Christmas, which is probably why some of you don't remember it right now. So anyways, so if I'm going to find this thing, I need to do the volume equal to the base area times the height of the whole object. Now in this case, the base area, since the area of the base is going to be a regular hexagon, the specific excuse me, the specific formula we're going to use here is 1/2 apothem times perimeter times the height. So this part's our area. Now we just found out that we've got the apothem, and we can actually find out the perimeter now, because this whole side length has to be 8. Why? Because half the side we just found out here was 4. So if half the side is 4, this is 8. So all of these are 8 here, 8 here, 8 here, 8 here, 8 here, 8 here. We've got 1, 2, 3, 4, 5, 6 8s. So the perimeter of that hexagon is 6 times 8, 48. So perimeter is 6 times 8, which is 48. All right, we now have everything that we need to do. Volume. They told me it's 912 root 3. Equals 1/2 apothem 4 times root 3 times perimeter. Perimeter we just found out was 48. Times the height. That's the one thing we don't know. All right, so let's just go ahead and multiply this stuff real quick. Half of 4 is 2. 2 times 48 is 96. So this is 96 root 3 times the height. Now to simplify this a little bit, I don't like those root 3s, so let's just divide both sides by root 3. And we get 912 equals 96 times the height. And so now in order to find the height, all I have to do is take 912 and divide by 96. And it comes out to 9.5. So our height is 9.5. What's our units? Centimeters. There we go. One last problem, and then we're good to go. All right. Square pyramid. Okay, let's write down our equation. Volume equals base, 1/3, because it comes to a point. 1/3 base area times the height. Now, since our base is a square, then the base area is just the side squared. All right, let's see what we got here. So we've got the volume is 216, so we're going to plug 216 here. The sides are 6. And then the height, that's the one thing we don't know. So we're going to find that. Okay, so this is 216 equals 1/3 times 36. 1/3 times 36, so this is 36 divided by 3. And then we can just take 216 and divide by 12. And we get 18. So I now know that my height over here is 18 feet. So find the height. Height is 18 feet. Now that's this number here. So that's 18. Okay, they want us to find the lateral edge. This is a little bit tricky. So I've already talked about lateral height right here. We want to find the lateral edge over here. And so here's what we can do to find that. So I know that if I go ahead and solve for the Pythagorean theorem here, I can find the slant height, the lateral height right there. So I'm going to do that real quick. I'm going to do 18 squared plus 3 squared, and then equals the lateral edge squared. So 18 squared plus 3 squared equals the slant height or the lateral height squared. So 18 squared, what's that, 324? 18 times 18, yeah, 324. 3 squared is 9. Okay, so we end up with 333. Okay, then I'd take the square root from both sides. And I'd get that the slant height is equal to, well, it's just going to be the square root of 333. No. 9 goes in there. Okay, 3 goes in there 111 times. And 3 has to go into that. Oh, I forgot about that. It does reduce. 5 on 3 comes out to 37. Almost forgot. So I end up with 3 root 37. All right, so that is L right here. Now what I'm going to do is become really tricky. I'm going to make another right triangle over here. Remember, I'm trying to find my lateral edge right over there. So over here, I've got another right triangle. Now, if this is 6 and this side's 6, what we would get right here is half of that 6. So now I can do 3 squared plus the slant height squared, or the lateral height squared, equals the hypotenuse squared, which is the lateral edge. So I'm basically going to do the Pythagorean theorem twice. So I'm going to do L squared plus 3 squared equals the lateral edge squared. So we already said that L was the square root of 333 plus 3 squared equals the lateral edge squared. So squaring a square root, that just becomes 333. That's plus 9. And then I get 342 So I'm going to take the square root of both sides here. I'm just going to plug it into my calculator because I really don't feel like doing this right now. 3 root 38. Thank you, calculator. So this reduces to 3 square root of 38. So our lateral edge reduces to 3 square root 38, and this is in feet. There's my lateral edge. So just recap, to find the height, I used the volume formula, plugged in the side squared and the volume, found the height. I used the height, and it looks like half of my base here, this 3 right here, and used Pythagorean theorem to find the slant height. And then I used the Pythagorean theorem again for this green triangle that I drew, slant height, this edge, and then the lateral edge over there. Tricky, tricky, tricky. All right, math it up. Math hard. That's all I got for you this year. See you later. Bye.